A human born 200 years from now might have genetically repaired DNA, microscopic sensors constantly monitoring their blood, and an immune system stronger than anything evolution ever gave us. They might live for 150 years, maybe even 200. And yet somewhere inside that nearly perfected body, a single cell could still make one tiny mistake. It could refuse to die. It could begin multiplying. And suddenly, even this future human could have cancer. That creates a strange possibility. The better we become at defeating cancer, the longer we live. And the longer we live, the more opportunities cancer may have to appear. So will future humans finally eliminate one of humanity's deadliest diseases? Or is cancer something that can never truly disappear? To understand the future, we first need to understand what cancer actually is. Most people think cancer is a virus or a random sickness you catch. But that's not true. Cancer is a failure of communication. It is a civil war inside your body. Think about your body for a moment. It is the most complex machine in the known universe. You have about 30 to 40 trillion cells inside you. That is dozens of times more cells than the estimated number of stars in the Milky Way. Every single second of every single day, these cells are working in perfect harmony. They know when to grow, when to stop growing, when to repair themselves, and when to die. In a healthy body, this is a beautiful symphony. But sometimes, a cell gets a bad piece of information. Maybe it's from radiation. Maybe it's from a chemical we breathe in. Or maybe it's just a random mistake when the cell was copying its DNA. When this happens, that cell forgets the music. It stops playing in tune. It stops listening to the conductor. And instead of dying like it should, it starts growing out of control. It doesn't just grow. It mutates. It becomes selfish. It steals nutrients from your healthy cells and hides from your immune system. Cancer is unusual because the enemy isn't foreign. It is you. Or at least a cell that used to obey the rules that keep you alive. Cancer is evolution happening inside your body, with damaged cells competing to survive. And that is what makes eliminating it completely so difficult. As long as cells divide, mistakes will sometimes happen. Every time DNA is copied, there is a possibility that something changes. And there are trillions of divisions happening in your body right now. DNA damage and mutations are constantly occurring in our cells. But most never become cancer. Cells have repair systems, self-destruct mechanisms, growth controls, and immune defenses designed to stop damaged cells before they become dangerous. You are winning this battle right now. But here is the shocking truth. Even if we eliminate all the pollution, all the cigarettes, all the radiation, and all the carcinogens in the world, we still would not eliminate cancer. Why? Because one of the strongest risk factors for cancer is something none of us can completely escape. Age. The older you are, the more times your cells have divided, and the more chances there have been for mistakes. That is one reason cancer becomes dramatically more common as we age. And this creates the first problem with our dream of eliminating cancer. But there is another problem. A strange paradox. The very technology that could save us from cancer might accidentally give cancer more opportunities to appear. If we cure all the diseases that currently kill us, we live longer. And if we live longer, our cells have more time to accumulate dangerous mutations. So the better we become at defeating cancer, the more chances cancer has to appear. Could curing aging actually make cancer an even bigger biological challenge? That's a strange question. But nature may have already given us part of the answer. There are some large, long-lived animals that seem surprisingly resistant to cancer. Take elephants. They have many more cells than humans. They live for decades. So you might expect them to develop cancer far more often than humans. But surprisingly, they don't appear to. Why? They have evolved unusually strong tumor suppression mechanisms. Their bodies are just better at killing mutated cells. This mystery even has a name. Peto's paradox. Large, long-lived animals should theoretically accumulate huge numbers of potentially dangerous mutations. Yet species such as elephants don't experience cancer at the rates a simplistic cell number model might predict. Evolution has already discovered biological strategies against cancer. So what happens when humans learn to copy them? Future gene therapies might borrow principles from animals that evolved unusually powerful cancer defenses, strengthening our own tumor suppression systems. Instead of waiting for evolution to give humans better defenses over millions of years, biotechnology could potentially accelerate the process. The first layer of the future may be prevention. Gene editing could eventually attack cancer from several directions. Instead of trying to rewrite every cancer cell inside a tumor, which is an extraordinarily difficult challenge, scientists may be able to genetically modify immune cells so they recognize cancer more effectively. They could disable specific molecular pathways tumors depend on. They could correct inherited mutations that dramatically increase a person's cancer risk. The ultimate goal might not be repairing cancer after it appears. It could be making the human body far harder for cancer to exploit in the first place. Could we engineer humans who are naturally more resistant to cancer? That is a very different question from asking if we can cure it. Today, genetic screening can identify inherited variants associated with unusually high cancer risk. Farther into the future, gene editing might theoretically allow some inherited risks to be corrected. But editing embryos in ways that pass to future generations remains scientifically difficult and ethically controversial. However, even stronger DNA defenses still wouldn't catch every cancer. That's where the second layer begins. Detection. Researchers are developing blood tests that search for molecular traces released by tumors, including fragments of tumor DNA. The hope is that future versions could identify some cancers far earlier than today's screening methods. Imagine eventually detecting the molecular fingerprints of cancer before a tumor becomes large enough to cause symptoms.
Your future doctor might not be the first thing to discover your cancer. An AI continuously analyzing changes in proteins, DNA fragments, and medical scans could notice something is wrong long before you feel sick. That changes everything. Because if cancer can be detected before it becomes dangerous, something strange happens to the meaning of the word cure. And once cancer is found, the third layer begins. Destruction. One of our most powerful tools is immunotherapy, which helps the immune system recognize or attack cancer more effectively. Cancer is sneaky. It hides. Immunotherapy takes the invisibility cloak off the cancer. It tags the cancer cells and says to your body, look, these are the bad guys. Your own immune system, which is incredibly powerful, then goes in and destroys them. Farther into the future, nanoscale delivery systems, and perhaps eventually microscopic robotic devices, could navigate the body and release treatments exactly where they're needed. You might have your tumor biopsied and genetically analyzed, then receive a personalized cancer vaccine designed around the unique mutations inside your tumor. That vaccine could help teach your immune system which cells to attack. It is not a one-size-fits-all cure. It is a personalized solution for a personalized problem. So will future humans still get cancer? Probably. As long as our bodies contain trillions of cells that divide, mutate, compete, and age, the possibility may never disappear completely. But that may not be the future that matters. Because a future human could develop the first dangerous cancer cell on Monday, have it detected before a tumor ever becomes visible, and have an engineered immune system destroy it before they ever feel sick. Technically, cancer appeared. But did that person ever really have cancer in the way we understand the disease today? That may be where medicine is heading. Not toward a world in which biology never makes mistakes, but toward a world in which those mistakes are detected and corrected before they can become tragedies. For some cancers, a diagnosis in the future might eventually feel less like a death sentence and more like a serious but manageable medical problem. Perhaps one day, certain cancers could even become as routine to treat as problems that once terrified previous generations. None of this future is guaranteed, but pieces of it are already beginning to appear. The future isn't arriving all at once. It's being assembled piece by piece. And perhaps the strangest part is that defeating cancer could create an entirely new problem. If humans stop dying from diseases that have killed us for thousands of years, how long could the human body actually survive? Because cancer may not be the final enemy. It may simply be one of the last barriers standing between humans and a radically longer life. So will future humans still get cancer? They may still develop cancerous cells, but they may rarely experience cancer as the disease we know today. And that might be the most important distinction of all.